In this particular tutorial, we'll be doing course to steer. Question 3 on page 17 of the RYA Dayskipper exercise booklet. At 10:55 daylight saving time, Tuesday 28th of May, a boat's leaving the anchorage, Stubbington Bay, 46 degrees, 18.28 minutes north, 006, 11.17 minutes west, and it's heading for a waypoint half a mile due west of the West Point Ledge Red Buoy. And what we've got to do is to work out the magnetic course to steer with the boat speed at 10 knots. And how far off the headland at Hill Head will the boat pass? Well, here we are, Stubbington Bay. They've given us the latitude and longitude. So 46 degrees, 15 minutes, 16, 17, 18. It's 18.28. So use the plotter like a set square, 0.2, 0.4. So almost halfway between those two. Line it up and draw a faint line, and we can see that it goes through the anchor sign, the anchorage sign for Stubbington Bay. The longitude 006, 11.17. From the top of the chart, if I find 11.17 and draw a line down, once again aligning it this time with the latitude line, it goes through the anchorage, and that's where we are, Stubbington Bay. Like I've said with all lat and longs, do check them. It's very, very easy to plot it incorrectly because two lines will intersect. If you've got one of the line, the latitude or the longitude incorrect, you'll end up with the wrong position, and it won't be immediately obvious, although this looks pretty good that we're in Stubbington Bay and there's our starting point. Now we're actually going half a mile west of the West Point Ledge Buoy, and here's the West Point Ledge Buoy. So we put half a mile on our dividers. Each of these is a mile, and due west we can use this as a set square, lining up with one of these lines, or we could set 270 actually on the plotter, and there's 270, and align it with north upper edge on the West Point Ledge Buoy, and we'll end up with the same. Let's draw a line through, measure half a mile, and that is 270 West Point Ledge Buoy, 1.8 miles, which is how you'd normally write it or say it. And I've given that waypoint 1. Now the next stage is to go into the other information it gives us, and I do recommend the use of a navigator's notebook so we can write down all the information and make sure that we don't make any mistakes. It's Tuesday 28th of May, we're anchored in Stubbington Bay, and our ETA, estimated time of departure, is 10:55 minus 1. There's our waypoint, 0.5 miles, 270 degrees from the West Point Ledge Buoy. Victoria high water, we take the sum of the tide tables. That morning it's 11:25, and I've put the time zone of 0, and it's 5.5 metres. 12:25 is minus 1 for daylight saving time. Low water, 0.8 metres, so the range is 4.7 metres, which makes it a spring tide. Now you'll recall from other tutorials, what we do now, we want the time at 10:25. What is the tide at 10:25, 11:25, because we're actually departing at 10:55. So at 10:25 it's minus 2, because it's 12:25 high water Victoria, so it's 2 hours before, 1 hour before. We want 10:55, which is halfway between minus 2 and minus 1, exactly 30 minutes. So by convention, at 10:55, we use minus 1. If it were 10:30, we'd use minus 2 for 25 minutes. But because it's 10:55, we'd use minus 1 for the entire next hour. We go to Diamond Bravo B, and we can see that minus 1 hour, the tidal stream is 165 degrees at 3.2 knots. So the next stage is to work out the course to steer. Now the fundamental difference between the course to steer and the previous exercises we've done, dead reckoning and estimated position, is what a course to steer does is allow you to follow this track. Now this is the position in Stubbington Bay, 46 degrees, 18.28, north 006, 11.17 west, and as you can see it's on the anchorage symbol here. 10:55, that's the time we're due to leave. Here we have half a mile west of West Point Ledge Buoy. 1.8 West Point Ledge Buoy, 270 degrees, and that's waypoint 1. If we draw a line between the two, it's 304 degrees, and this is the course to make good. It's not the course to steer. So in other words, we want to follow that track. This is pilotage, as opposed to monitoring the course steer to see where we end up in relation to our estimated position. The danger of that is you can set into dangers, navigational hazards, fetching up, running aground before you have the opportunity to correct your heading. What a course to steer does is to take into account the expected tidal stream and to work out the course to steer in order to follow the planned track. Now, we worked out that the tidal stream was 165, 3.2 knots. So we put 165 on the plotter, 165, and we rotate the plotter around so it's aligned with north, and here I'm just using the latitude line, and we draw a faint line. And we put 3 arrows on here to show that it's the actual tidal stream. Now, if I used 3.2 knots, which is the tidal stream, we're going to end up with quite a large triangle. So I'm going to work at 30-minute increments. So 3.2 in an hour, 3.2 miles in an hour is 1.6. 1.2, 4, 6, 1.6. And that is the distance would be set by the tidal stream if we simply got underway and drifted. That's what we'd expect. And this is 1.6. Now I'm using a 30-minute increment for our speed. Our speed is 10 knots. So we're going to measure 5 nautical miles, half of that, and that equates to the distance we'd cover in 30 minutes. Right. This is the most important thing. Put it on the end of that tidal stream, and then where it intersects our planned track. This line, then, is the course to steer. So let's move that over, and we'll rotate the bevel round to get the course to steer, and we can see that it's 317. So let's write 317 degrees. That is the course to steer. The most common error is from this point here at the end of the tidal stream to the waypoint. If I just faintly draw that line in, if we steered this course, then we'd have to travel at that speed. And if I just put that on the latitude scale, that is 6.8. So we'd have to go at 13.6 knots, but we're not, we're doing 10, which is that 5 mile line there. So we're going to steer 317. 304 is what we want to make good. That's how we'd expect to travel over the ground. And we measure the distance between the two, 10:55 to this position here, which will be 11:25, and that will be the estimated position. We're steering 317 on leaving the anchorage. That's the heading of the boat, but we're going to track along here and be here at 11:25. The speed of the boat will be 3.6. 123.6, 3.6 miles in 30 minutes, double it because 30-minute increment makes 7.2. So we're making 7.2 knots over the ground on a heading of 304. We're steering 317 true, but through the water at 10. So you can see we're losing several knots of speed over the ground, simply due to the tidal stream setting us down to the south, which is what we'd expect. With regard to calculating the course, we want 307, which is our true course. The variation is 6 degrees west. So, as I always say, compass to true, add east, subtract west. Always write it down. Add east, subtract west. 307 is true, so we put it on this side. We're going in that direction, so we add west because we're going to the opposite direction. So it's 307 plus 6 degrees gives 313 magnetic. And that is how we calculate the course to steer. And that's to show I live near the sea. That's the Coast Guard helicopter. So 307 true, 313 magnetic. So we steer 313 magnetic, 10 knots run on, and we make 304 at 7.2 knots. Part of the calculation is to work out how long it's going to take to get from the Stubbington anchorage to the West Point ledge. So what we do, we measure the distance, and here 1, 2, 3, 4, 5.6 nautical miles. We've worked out the speed over the ground is 7.2 knots. So the calculation is very simple. Again, back to our navigator's notebook, 5.6 miles, 7.2 knots. Distance divided by speed equals time. 5.6 is the distance, 7.2 is the speed. If we did that calculation, that would end up in fractions of an hour, because this is 5.6 nautical miles divided by 7.2 nautical miles per hour. So if we multiply it by 60 minutes, we'll actually get the answer in minutes instead of fractions of an hour. And there it is, 47 minutes. We're leaving Stubbington Bay at 10:55. It's going to take 47 minutes, which means we're going to arrive there at 11:42. And it will work out that accurate. It will be minutes if you follow this calculation and you're very precise in what you do. So that's it. Course to steer. One of the most important things that anybody navigating needs to understand: how to work out a course to steer to maintain the required track. That is pilotage.